we're going to start. Yeah, so to kind of go over main ideas, we're going to be talking about rules for graphing, and these are sort of hard and fast rules that will need to be followed as you're choosing an appropriate data visualization. But then we're also going to spend a considerable amount of time talking about the art of graphing, and these are sort of the things where there is no one right answer, but we're going to talk about all the types of little things that you can do to make a better graph and more effectively communicate with data. And these are the kinds of things you're going to want to pass on to your students when they're creating graphs in the context of some assignment, or if they're competing in a science fair, or they're giving some kind of poster presentation with data. These are all the art things and the small things you can do to improve that data communication. So I'm going to begin with a story, and I'm hopefully I'm not walking too much of a tightrope with a high concept here, but this webinar is about telling a story with data and how you can do that better. But first, I'm going to tell you a story and then show you the data from that story. So this story is from my own classroom in the Chicago Public Schools. This is back in 2010, which is starting to seem like a long time ago now. But this is I'm going to talk about a research project that I did with all 5 of my classes. So it was 1 section of zoology elective and 4 sections of regular bio, which were 10th graders. And this happened at Thomas Kelly High School, where I worked for 7 years. I'm going to give you a quick bit of lizard biology needed to follow this example. And if you were at our webinar last week, we also worked in some of this lizard biology. But first thing I want to say by way of background here is that the egg environment is very, very important for the development of a reptile. And some factors that can be really, really key in how that embryo develops are things like temperature and moisture. And this is particularly true in reptile eggs, which have very porous eggshells and exchange a lot of moisture and gases with the outside world. This egg environment can have consequences that affect the traits of that developing animal. Things like body size, color, running speed, all of these things can be affected by that egg environment. And those traits in turn can affect, the fate of the animal, whether that animal lives or dies, that offspring's survival. So that maternal choice of nest site ends up being a really, really important choice that can have a cascade of consequences that literally translate to life or death for a baby lizard. Okay, so there's a quick bit of lizard biology needed to follow this example. So now we will return to me telling a story from my own classroom. And I want you to think about these rules for graphing as I tell this story. Format your data by thinking in terms of variables, and this very much aligns with the idea of tidy data that if you've been to some of our other webinars, you've likely heard us talk about. And select your visualization based on your questions and variables. So the questions that my students and I settled on, there's actually going to be 3 questions. And this first is a pair of questions. And it was, do female brown anole lizards prefer wet soil when deciding where to make a nest? And do female brown anole lizards prefer to nest near plants? Does the presence or absence of a plant matter in this case? And both of these questions, when we were doing this experiment in my classroom, I wanted to really make it clear to my students that these were questions that were at the time unanswered by science. So I had spent some time in the summer thinking about these questions, thinking about something that was unknown to science and something we could realistically answer in the course of the semester. And that got the kids really excited, because from the beginning, I let them know that they had the chance to contribute to the mankind's knowledge on this very, very narrow scientific topic, and that's what science is all about. So to think in terms of variables here, to answer these questions, there's kind of 3 key variables here. One, there is the soil moisture, and we presented lizards with 5 different choices of soil moisture, 5 different levels of this categorical variable. And then we also presented those choices both with and without a plant. So this is another categorical variable, this presence or absence of a plant. And then we also recorded which tank, which aquaria this was recorded in, because the scale of this experiment, we had 20 different aquaria set up in our classroom. And that was an important variable. And I'll talk more about the design of that as we move forward. So these are first 2 questions, but then we had a third question. And this was, does the incubation soil moisture affect the body size of a hatchling lizard? Okay, so does this incubation moisture, so in a sense, how does a female make this choice? And then what are the consequences of the choice, right? So we're looking at, is moisture important in the choice? And then does it have an effect? And for this, the variable, there's just really 2 that needed to be recorded here. The one variable is body size, and this is specifically the body size of the lizard at hatching. And second, incubation moisture. What was this was essentially a treatment or a categorical variable of what treatment was this lizard incubated at. And what we did is we sort of set up 2 different designs for each of these different experiments. The first design is what's called a 5x2 factorial design, where you have a factor with 2 different levels, and that's your categorical variable of plant or no plant. And you can see it in this diagram. The ones that have a plant present they say plant, and the ones that do not have any word there. And then we had 5 different moisture treatments. So they range from 0%, 12.5%, 25%, 50%, and 75%. So these are all soil moisture treatments. Also, we're considering this a categorical variable. In a sense, it's 5 different treatments. And we repeated each of those 5 treatments 2 times with and without a plant. That's why it's called a 5x2. And then we multiplied this by 20 replicate aquaria. These are just 10-gallon aquaria tanks. And so each aquarium looked like this. And if you were with us at the last webinar, you saw this design, but you see here, there's 10 pots and 10 nesting boxes. And what those are is it's 5 different moisture levels in the soil, repeated twice, once with a plant and once without. So this was our basic design here. For the second question, or the third question rather, does the incubation soil moisture affect the body size of a hatchling lizard? We harvested those eggs once the female had laid them, and we tried to harvest them very, very quickly within a day or 2. And then we placed them for their 30-day incubation period. We placed those eggs in a little petri dish, like you see in that little image on the left, and we packed it with soil that was calibrated with a different moisture treatment. So one of those 5 different moisture levels. And then we raised those eggs, we hatched them, and then measured the body size of the lizards that hatched out. So that was our basic experiment. And so what did we find? And now we're going to return back toward these tips for communicating with data. And I'll just say, there was a lot of excitement for this assignment in our class, and we worked on this on and off for about 4 months in my class. We moved the lizards into their tanks. The whole setup looked something like this, and students took full responsibility for both caring for the animals as well as collecting the data. And my classroom, became chaotic on many days, but in a very, very good way. The sort of best kind of engaged chaos where students are really, really feeling like they're doing something. There was a lot of really great teamwork on this, and interest remained high, and it had all sorts of different teachable moments along the way, both biological concepts, but also all sorts of things related to experimental design. And we were able to use this assignment. It was really the anchor for our biology course and our zoology course in that year. So getting on to results, and now we're going to kind of get back to the main thrust what we hope is going to be most valuable to you. And that is this communicating with data, both following these rules for graphing and the art of graphing. And so in this graph here, you see that we've plotted this categorical data, and there's two categorical variables represented here. There's both the soil moisture treatment, which had 5 different categories, and then there's the plant presence, which had 2 categories, yes and no. And so, different options we could have used for graphs here. We could have done a categorical bubble plot. We could have done a bar chart with separate bars, like a split bar chart, or what you see here is we went with a stacked bar chart. But those choices are all dictated by the types of variables. There's not a lot of wiggle room. We could really only choose between a few basic types because we wanted to show these 2 categorical variables. And within DataClassroom, this is where the role of the graph wizard comes in. And when we go on to other examples, I'll show you how the graph wizard sort of guides you through the rules for graphing to get you to an appropriate graph. But with the art of graphing here, there's a number of choices we made. And the things we want to keep in mind is, what are we trying to communicate, and are we communicating effectively? And with this, the 2 main things that we are trying to communicate, I've listed those up at the top. And those are, one, that females show a strong preference for high soil moisture when selecting a nest site. And that is really shown by the height of the bars. And you can clearly see these data are so clear that the 50 and 75% bars are just so much higher than all the others. And so that pretty clearly communicates that first point. And then the second point is a little bit more subtle, and it's a negative result in that it turned out females don't show any preference for the presence or absence of a plant. And this is a classic chi-square kind of analysis, and that's of course what we reported in the paper. But visually communicating that result, I've chosen to go with the stacked bar chart here, because when you kind of glance at the bars, particularly the 50 and the 75% bars, they're split pretty close to evenly between the purple and the teal, between the yes and the no. And so it really sort of emphasizes the point that there's not much difference there, and it makes it easy for your eyes to see. So I wanted to share that result with you, and then a little later on we'll go through how you can use Graph Wizard to help you through those choices, and then we'll also break down the art of graphing with some more examples. I want to convey the second result, and I'll also say if any questions come up, please feel free to just drop those in the chat, and we can take some questions as we go. But the second graph, this is the question of, did incubation moisture have an effect on body size in these lizards? And the data you see here, we present 3 different incubation treatments on X as 3 different categories. And then we display the mass of the hatchling lizards. And again, if you're comparing groups, the options that you can, solid options you have for comparing groups are, you could do some kind of stacked histogram where you show the distributions of the 3 different treatments, or you can do some kind of a dot plot like I have here. And then with that dot plot, you could add a bar showing the mean, or you could add a dot and error bars are showing the mean, or like I did here, you could add the box and whiskers to highlight the median and show the data points. But one thing I want to point out here, I think you should never, with this kind of data, use a bar graph without error bars, because a bar graph without error bars to make this comparison between groups, when you actually have numeric data, you're really concealing a lot, and you give your reader absolutely no way to tell if the difference in means is meaningful, because the reader can't see anything about the variation it's completely obscured and hidden, and they can't see anything about the sample size as well. And so what you see in a graph like this, where you see the dots are actually left on the plot, they're sort of superimposed over the box and whiskers, you can see the actual data as well as see the median and the interquartile for each group, as well as the range for each group. And so definitely, if I leave you thinking that you should not report means as bar graphs without error bars, I think that's really important. And then you have a high potential to deceive a viewer if you have nefarious intentions, or just mislead a viewer if you're just doing it because you just didn't realize that. So that is the second result, and I want to now kind of go through some more of these examples, and then we'll actually jump over into DataClassroom and work through some of these examples. If anyone has any specific questions on these, we can definitely go back to these. I put up this slide here just as a reference, because remember, we're gonna email these materials out to you. If you registered for this webinar, we'll send this to you within the next few days. But these are some guiding principles when thinking about rules for graphing. Data formatting is really, really important. And you want to make sure that you identify all relevant variables, organize your data sheet by those variables with where each variable gets its own column. And then you want to choose the type of variable correctly so that you can get to the options that you want. And so, this is things like thinking about, is it numeric, is it categorical, is it sample count? In most cases, if you've organized your data in a tidy fashion, numeric and categorical are going to cover 95% of your cases there. And then when you're setting up your visualization, you're going to want to generally, and there are exceptions, but you're going to generally want to put your independent variable on X and your dependent variable on Y. And then also know that if you have a meaningful third variable, which is oftentimes a second independent variable, in DataClassroom, that can appear as a Z variable. And that is sometimes color coding your data points or splitting them out in different ways. So know that that is an option. And then when graphing, again, keep in mind, what are you trying to communicate, and am I doing it effectively with the present graph? And things to think about is how you can use color as an extra communicator, how you can use space to demonstrate relationships. And this is thinking about things like the shape of your graph. Do you want a square? Do you want a rectangle? Can I jitter my dot plot? Do I want to use bigger points, smaller points? All of those things can come into play. And then when you're choosing to display a measure of central tendency, I think in general, if you have normally distributed data, probably want to show the mean. If you have really non-normal data or otherwise kind of wacky data, sometimes it's better to show a median. And then using appropriate labels for your final product. And by that, I really mean to think about physically, where is the graph going to appear? Is it going to appear on a poster and it's going to be quite large? Is it going to appear in a paper where the graph is going to be quite small? And as you think about how to size your axis labels, that can come into play.
Aaron, one last thing to add, just while we're on the slide, is that we kind of intentionally have the rules organized a little bit more strictly, because compared to the art of graphing, the rules are pretty straightforward. There are things you almost want to knock out in a checklist type order as you're creating a graph, whereas the art of graphing, it may not be a totally linear process. We talked a little bit about in our last webinar about how you have to have kind of the end in mind as you're creating, and it might be something that your students realize as they make different versions of the graph, that they need to change the color to communicate something more effectively, or that once they begin to see a pattern in the data, that discovery can help guide different changes that they're making. So it's not necessarily a one-way street when you're working on the art of graphing. Something you do maybe back and forth on as you fine-tune it to represent exactly what you want to say.
Yeah, that is a great point, that idea that there's not necessarily a right answer when it comes to the art of graphing. And oftentimes what you'll be doing is make the graph one way and then say, I don't like that color, or I can maybe fill that space by making the dots bigger or something like that. There is it is truly a little bit of an art. So let's take some examples here, and we're going to go through kind of a basic graph. And there's nothing wrong with any of these basic graphs. These are essentially what the default graph will look like in DataClassroom. And I also want to say that oftentimes, we have tried to design the default graphs in DataClassroom to look as good as they possibly can visually. So we've made a number of choices about what the default settings are that might already look a little bit sharper than, say, an Excel or a base R plot or something like that. But so this is a data set that's in DataClassroom. This is the NASA feeling the heat data set, and this is the basic graph. If you want to get a relationship between this variable called year and this variable called average temperature anomaly, this is what you'll get. And then I'm going to show you a number of changes we've made to this same data set, and that looks like this. And it's not to say that, again, the graph on the left is fine. You can clearly see a fairly strong correlation with a big data set, strong correlation between year and temperature anomaly. But in the graph on the right, we've taken that same data set and we've just sort of enhanced the way we're communicating with the data. And I want to take you through, some of the specific changes that I've made here. Number one, we've gone with smaller data points just so that you can see the density of the points a little bit more. The cloud on the left with those very large data points is just so crowded and stacked on top of each other that it's a little bit hard to truly see, how much thinner the bottom left corner of the data cloud is and the upper right corner or the upper margins, because it just sort of looks like a solid mass of points. But when you shrink those down to a smaller point size in the appearance menu, and everything I'm showing you here is in the appearance menu, and we'll work through an example, but I changed point size as my opening. And then the other thing we did here is I added this additional variable of latitude zone, which is a categorical variable. I added that to the plot, and it color codes all of the points by low, middle, or high latitude. And then with the line of best fit, I also checked the option to group by Z. So all of this is happening at the control panel at the right. And so now I can explore, the subtle question, despite there being the overall upward trend of average temperature anomaly increasing with time. Now we're able to ask, a more subtle question about, is that relationship different among the different latitudes on the planet? And so you can see, there's a lot more information. I see a question in the chat. Will the webinar be recorded? Yes, it will, and we will automatically send the recording out to everyone who registered. Okay, so this is example basic, and then a more advanced graph. Let's walk through another one here. So this one is from a data set in the DataClassroom resource library that's called Snapshot of Biodiversity. And this was looking at different camera traps that were placed by researchers in the Peruvian Amazon, and they were placed at naturally occurring salt licks. So we have salt licks labeled A through L, and then we have 5 different mammal species that we're seeing here. And those are the 5 different colors you see. And then the heights of the bars were the number of sightings at each of the camera traps for them. And this graph is fine. Again, this is a perfectly appropriate graph. If a student made this, there's no definite problem with this. However, I think you can enhance it, because one sort of downside of this sort of split bar chart like this is that it's a bit busy, and it's kind of hard to see where one salt lick begins and ends on the axis, because some of them have 5 bars, some of them have 2 bars, some of them have 3 bars. And so what you could do is you could take that same graph, on the left as your starting point, And then you can play with the appearance to get this kind of graph. Exact same data, exact same message, but it can be a little bit faster to communicate this. So, the point of this is wanting to show the diversity among each of the different salt licks, and seeing, if they vary. So you're looking for each of the colors represented within a single bar, because now each salt lick has been collapsed to a single bar. And so you can now much more clearly see A through L as separate entities. And then and with more surface area being covered with those colors, you can see that. And so what we did here is we went into the appearance menu and we clicked the option to make this as a stacked bar chart. And that's the very first option you'll have if you open the appearance menu. And then the other things we did is we increased the size of the axis labels as well as the x-axis markers. So that's the x-axis markers are the A, B, C, D, etc. under there. And that, that makes that graph, I think, a lot more readable. One thing I didn't do that you could do if you just strictly were interested in comparing diversity across these camera traps, but you weren't interested in comparing the total number of visits, you could make this stacked bar chart to show proportions. So the height of all the bars would be equal, and the y-axis would then instead show you the percentage of visits rather than the raw numbers of visits.
And I'll just add the two things that really jump out here out of kind of our 4 suggestions in the art of graphing. There's use color as a communicator. And this one very clearly has colors that are easy to separate among the 5 different species there. So that helps communicate an idea about the data. And also there's just the importance of spacing and the relationship that spacing in different elements has to one another. In the basic graph, there's very clearly something interesting going on, but you alluded to how crowded it is. So we can't really discern what's going on at licks 5, F, G, and H. But by having the spatial relationship of the rectangles within each bar, as well as the more clear definition of each lick to one another, we're using the spacing and the negative space of the graph to better demonstrate the picture of the data.
Yep, definitely. Good points for sure. And Blake, keep those in front of you, and as we go through here, definitely allude to those. Again, I think that was a really helpful comment. Okay, let's take another one. This is data. These data were collected with a pedometer, and it was measuring the cadence of different runners running with shoes or shod, and then running barefoot. And this is a really simple kind of classroom experiment. This was actually done with a vernier pedometer, and so you can see the running cadence. So each of these dots is actually paired, and you can't necessarily see that here. So want to just go in. I see Blake has asked the question of what can we improve about this graph, and so thinking about things, how can we use color more effectively, how can we use spacing, are there any additional visuals? And there's actually a lot of different things we can do here. And I'm gonna show you a more advanced version of this graph. So here's a graph that really has quite a bit more information with the exact same data. And so one thing we've done here is, instead of using that jitter, we've now reduced the horizontal jitter to 0. So all of the points fall in a straight line. And we did that so that we could add these connecting lines where we're connecting the identities of the runners by their test subject ID. And so each pair of dots that are connected are the same runner. And so you can see their test subject ID over there in the legend. And it really shows the impression about, there's a lot of variation among these different runners in their running cadence, but you can see that the vast majority of the lines slope up to the right. When they're running barefoot, their running cadence increases. And then even beyond that, you can see the 2 different runners who actually, had the opposite trend where they went down in cadence when they ran barefoot. And then, you expect that when you're collecting a data set. It's the very reason why you collect, more than one data point when doing that. Okay, so we've gone through a few examples. I'm going to show one more, but then we're going to actually open up a data set, and you can play along at home if you want to open up the same data set, and we're gonna kind of go through it in real time and explain kind of how we did. But I am going to show you the endpoint first, and then we'll take our time and we'll walk you through how to get to that endpoint. So going to, oh, sorry, wait, not quite yet. I've got one more example. We'll go through this one quickly, and then we'll go through the one where we really walk through. So basic version of this graph, just a jittered dot plot. We didn't manipulate color or point size. This is just the, the default graph you will get. And it's fine. But the more advanced graph here, we've done some things with color. And what we've done is, because this sucrose concentration, these were 5 different treatments of sucrose concentration that you see displayed along X. We've chosen colors that go along a gradient from green to blue, and to show that the sucrose concentration is increasing from 0 to 1.0. And so that, those treatments in themselves are a gradient. And so we've chosen colors to represent them. We've also added the box and whiskers so that you can clearly see the median and interquartile for each group, with just a measure of central tendency to help make a comparison among groups. And at the same time, when we've done that, we've reduced the point size and taken away the outer ring of the points, just to make those fade into the background just a little bit more, to make the box and whiskers plots really pop and sort of draw your eye to those, but you can still see the raw data there.
And I've got a genuine question here. When we talk about how there's no right answer when it comes to graphing, how do you grade or like fairly and consistently assess student work when they're going to be submitting graphs that look very different?
Yeah, I love to think about a world where students' graphing skills are so good that you can like grade them on those kind of subtleties of their data presentation. But I will say, and maybe people can chime in if you disagree with me, but my experience is actually, I think a lot of times, what we're actually doing with students is trying to get them to arrive at it, even just the graph on the left. And then the situations where we might really be pushing them toward this enhanced in communication is a lot of times, like if you're coaching a science fair student. I mean, I think that's a great example where they're literally competing against their peers on their ability to communicate clearly the results of their experiment. I think that's the kind, the time and place you could push them a little bit more on their data communication. Maybe I could actually see, and I definitely got to this point with my own students of, hey, if you're doing some kind of comparison and you have replicates, can we see some measure of central tendency? So I might ask, are you showing me the mean or the median on there? Because that's, we need to see that in that comparison. But the subtleties of, did you use a box and whiskers, or did you use a mean and confidence intervals? Like, those are great conversations to be having with kids. I don't know that I would actually be grading on that kind of fine of a point. Good question. Okay, so now here we're going to get to the example that we're going to really walk through and show you exactly how to do this one. So this is a data set. Blake just dropped it in the chat if you want to open it up. This was an experiment where you have these paper towel types, and you have 5 different paper towel types plus a control, which is the school's brand of paper towel. And then you have absorption score. And when if you set up this with Graph Wizard, and it gives you this basic kind of a dot plot with no descriptive stats, the data are a little bit hard to read here. This is not a very quick graph to see trends with. And a more advanced graph would look like this, exact same data set, but we've just done quite a few things to make this result a bit more clear. And here you can see we've got 3 paper towels, Control, Brawny, and Bounty, which have relatively high absorption scores. And then we see 3 paper towel types, Scott, Sparkle, and Viva, that have low absorption scores. We will also say, don't disparage these paper towel brands. This is data that we have made up in this case, but we did base it on a real data set that was collected in a classroom very, very recently. So we're going to go through, how do we get from the graph on the left, which it's really challenging to draw a conclusion from, to the graph on the right, where there's a very clear conclusion. So let me, I'm going to stop my screen share for just a second. And I'm going to start a screen share where I go over to my data classroom window. And here, that was not the slickest, but I will get there in a second. Okay, so I'm my data classroom. I'm going to open up a data set. I know if I search the word towel in the data set list, I'll get it, comparing paper towel absorption. If you click that link that Blake put in the chat and you're logged in on data classroom, it'll take you right here. So this is the data set. And if we go through Graph Wizard, and again, this is in talking about choosing your variable types and getting you to the right graph. If we go through this, we need to think about what is the question we want to answer. And our question is, is there a difference in absorption among the different paper towel brands? And we took multiple data points of multiple trials of each of those paper towels. So we want to compare groups. So these are numerical measurements or the paper towel absorption scores. And we go in here, we go to compare groups, and which variable that specifies the group in this case is paper towel type. And what is the variable we're interested in? This is the absorption score. And we go and we see that we get these different options. All of these are valid. Some of them are going to be better communicators with data than others. Some of them might require more enhancement to get to something that communicates well. And so we're going to go down this and choose the grouped dot plot for this. And when we go down this path, I'm going to say, yes, show me the steps. And I'm going to say, do all the steps. And we're just going to go down the list, and we will arrive at this graph. Okay. And we've already talked about, there might be some differences among groups. It's hard to see them with this graph. So what are some things we can do here? So the first thing I would want to do is add some descriptive stats. And you'll see that's over here, the checkbox at the right. I'm going to add descriptive stats. And this is showing me a mean and standard deviation. Standard deviation is kind of large relative to these data. Also, standard deviation is sometimes hard to interpret in a comparison. So I might look for something that's a little bit more straightforward. And I'm just going to see how the 95% confidence interval looks. And I look at that, and that's showing some nice real differences with completely non-overlapping confidence intervals among the groups. Even though the data overlaps just between just about every 2 groups, some of these confidence intervals are completely non-overlapping. And this is starting to tell a real story that there's some differences here. It's still an incredibly busy plot here. So I might do some other things here, because we have 6 groups on the x-axis. I might reduce the jitter down to like 1 unit. That makes it a little less busy, but it's still fairly busy here. So I'm going to open up the appearance menu and start doing some other things to try to manipulate this. One tip I have, if I have a lot of data points on the screen, and you in the rings around the edge of the data points are making things busier than they need to be, I might go ahead and reduce that down to 0. And so that they kind of take on a little bit more of a ghostly look, where they don't have a hard edge, and they sort of fade into the background a little bit. And then I also might just reduce the point size of them down, like, maybe I'll take them down to like a 6 or a 7 there. And then another thing I'll do is I'm going to go down to the mean error bars box, and instead of positioning the dot off to the left, I'm going to change that position to the center. And so then there's a little bit more space, total space between groups. And then I'm going to do something like, I want to really enhance the mean and 95% confidence interval. So I'm going to increase the indicator width, and that makes my error bars go a little bit wider. And then I'm going to increase the line width on those as well to make them just heavier and darker. And I'm going to increase the dot size, so it really jumps out at us more than the background dots do. And what I'm doing is I'm pushing my comparison of means up to the foreground. I'm pushing the raw data to the background. We still want it there. It's still useful information, but we're gonna show that there. Blake, you look like you want to say something there.
I was just trying to time when the interjection made sense. I was just going to ask, so when we first looked at this data set, you like right away knew what you wanted to start working on. It's because you've got, decades of experience. What is kind of the question that you're answering, or what's the goal you're working towards as you make some of these changes? And maybe we could relate them to kind of the 4 guidelines for the art of graphing.
Yeah, excellent point. So keeping in mind those questions, right? So first thing I was trying to look at is, what is the story, so we know what we want to communicate, and what we want to, the question we're trying to answer with this data set is there a difference among the paper towels based on absorption score? And at first we couldn't really see that. Once we added the mean and 95% confidence intervals, now I'm pretty confident there is and we can run the ANOVA on this, but I'm pretty sure it's going to be significant. But we want to know, we want to then, once we determine that there is a difference between the paper towel brands in their absorption, then we want to do things that are going to highlight that difference. So, what can we do? We're going to, we started by using space to demonstrate relationships, and I decided to shrink that space between each of the groups to make them stand out more distinctly from one another. Then decided to enhance the mean and the error bars, because that really communicates that message in difference. And again, that's really, we're using space by making those larger, that allows us to make those differences show a little bit more clearly. And then the next thing I would do on this data set with that space to make the differences more clear is, if you want to sum up these results, you probably want to say, well, Control, Brawny, and Bounty had higher absorption. Scott, Sparkle, and Viva had lower. So one of the things I could do is change the order that they're displayed on this graph. So I'm going to go up to paper towel type, and I'm going to click on this values menu. When I click that, it opens this, and I'm going to move Bounty up so that it's next to Brawny and Control. And so now take a look at that. Just that one little change makes that look a lot more clear, because your eye just immediately, you say, oh, I see 3 natural groups here. Control, Brawny, Bounty seem to be sort of in one category. Scott, Sparkle, Viva, they are, sort of showing another. Another thing you might want to do with this data set to use color. I'll show you kind of 2 different things you could do that do 2 very different things. One thing you could do is, give each of these a different color so that they stand out from one another quite a bit more. And so I'm just kind of picking some colors that I like that look, very different from one another. Maybe we'll get a blue, and maybe we'll take like a pink there. So again, I just hit that values button. I can see each of the values of that paper towel type variable, and I give them each a color. And then when we go back here, now that message of, hey, we ran this experiment with 7 different treatments of paper towel type, that's just a little bit more clear to you, because it just jumps out when I'm looking at different colors. Your brain immediately thinks, okay, those must represent different things, so it splits them out. Another thing you could do with color in this case is if you wanted to maybe show which students collected which data points, you could add student as the Z variable. So I click show student, and then over here on the control panel, add it as Z, and the computer will generate this rainbow where each student gets a different color, and you can look for some patterns there. I'll say honestly, I don't really see anything when I look at this way, and so this would be an example of where I might try something, decide it's not a very interesting thing to the communication, and just go back to a simpler graph that I think communicates these differences more clearly. And then you get to here, and I think you get to a very clear result. Something you might do too is you might add a title to this, which of course, again, you can do that in the appearance menu. If you go, I've got to move my Zoom window here, but if you look to general, you can add a title, and then you can just click up here to add. I am a fan in general of titles that tell your readers what the main result is, and then they can look at the graph for proof. But like if I was writing a title for this graph, I might write something like Control, Brawny, and Bounty have higher absorption than Scott, Sparkle, and Viva, and I might just put that in there. Or I might say something like type of paper towels have different absorption scores as a title. Lots of times I know in middle school or elementary school, different rubrics coach students to make more literal titles, which sort of say like the absorption score as compared by paper towel type or something like that. But I would say more commonly among professional science, you will see titles that editorialize just a little bit, at least in scientific talks and poster presentations, where they communicate the main result, and then the graph backs that up. So.
Aaron, so while we're talking about labels on the graph, would you mind showing what leeway users have to change the labels along the x-axis? We had a question where we can change the color, which I don't think we have, but I know that there are some things we can manipulate.
Yes. So you have leeway, and this is important to think about, is where is this graph going to appear? Because if this graph is going to appear as a 1-inch square in a paper, then you really want to have large axis label size. So that's in general, and you can also experiment with fonts. But I recommend, if the smaller your graph is going to appear in print, the bigger the label sizes. So these labels, at first on a large computer screen, these might look ridiculously big. But if this is shrunk down to a 1-inch square, fitting within the text in a paper or a lab report, then I say that this looks really nice to have those large fonts. And then similarly, if it's going to be centerpiece on a gigantic poster, maybe you could go and make the decision to make those font sizes a little bit smaller. But I would in general challenge you to probably think about if you can use a bigger font size, because having a reader glance at your graph and immediately know what's on X and what's on Y can be really helpful.
And then how about if we wanted to change the shape or the orientation of the variable types, control, or variable names, Control, Brawny, Bounty, Scott, Sparkle, Viva?
If you want to change those labels, you could go. So if you wanted to change the labels that appear there, you could go right into the value, and you can change the labels in here. Like instead of Control, if I wanted to put school brand, you could do that, and it'll put that on there. Notice that automatically tilted these to be diagonal. I'm not a fan of that unless you truly have a large number of things along the x-axis. So if you want to game that a little bit in your visual and get those back horizontal so they're easier to read, you go into the general part of the appearance menu, and this is the x-axis marker size, and you shrink those to the point where they'll then appear horizontal when they have enough room. So that's another thing you can manipulate in there.
And I actually just wanted to share a point that Karen's made for the group is we've talked about considering where the final product is going to show up for like the size and the orientation. We also need to consider your audience, with the point being that how you label your data types is really important, because you wouldn't want to reveal, if you're using student data, we wouldn't want to use names. And if you're using brands as we are here, you might not want to bias people who are looking at the data. So we would probably come up with different names, as Karen suggested, for the brand names. They're like calling them paper towel 1, paper towel 2, so that the commercial and the marketing budget of Brawny paper towel isn't playing with people's minds as they look at the data.
Absolutely. And I think that that's good. Yeah, good practice as you go through it. But sometimes, if you have that's a thing to think about. Like, do you want your reader to immediately ascertain what the brand is, or is it more powerful by putting them into categories or giving them ID numbers or something like that? There's a question, a good question in there. Can you change the color of the paper towel names down at the bottom? You can't change the individual color of the lettering for those labels, but that is a really interesting idea, and maybe we will have that discussion at our next engineering team meeting if that's something we want to add. I think it wouldn't be too hard to add.
Do you think, is there a paper towel data emoji too for the different shapes?
I don't know. So yeah, you again in the appearance menu, and I don't have necessarily in mind a great way to do this, but if you want to replace these dots with symbols, you can represent them with the data emojis. And let me see if there is any paper towel in here. I don't know. There, we could do something like that, and make all of those into paper towels. Now we're really getting wacky. But
a slightly less frivolous question from the group. Can you change the axis max and min?
You can change the axis max and min. So to change the scale of the axis, that's also here in the scatter plot menu. So again, when you open up the appearance, that'll be here. And you can it's on auto scale for x-axis range and y-axis range. And you can do things like you can automatically include 0. Or here, I'll do that, sorry, for the y-axis. Include 0, and you can see there, now it's got 0 included in there. You can also do some things with fixed axes where, I can say I want this to go 0 to 10, and you can do that, and then it'll go 0 to 10. So you can manipulate that as well.
Or in this case, the scale that students were given to rate the absorption was 1 to 7. So we could, instead of using the fixed where you can't really tell that for some reason none of the paper towel met the expectations of students to earn a 7, we could throw that on there with the fixed.
And I want to actually see with the fixed. Let me see if we do it was 1 to 7. Let me see if it'll give me that. Sometimes it makes no, it'll give you 1 to 7. Yeah. So you just change that in the y-axis range. Another thing you can do, no need to do it for this data set, but if you want to reverse an axis, either X or Y, there's also a check for that. So if I wanted to make it go, 7 at the bottom and 1 at the top, I can do that, or flip it back that way. So you really have a lot of freedom to add things. You can even do things like add a Y reference line. Like, say we had some arbitrary measure, like a value of 4 or greater indicated a successful paper towel. You could do something like that and add a reference line at 4, if you wanted to highlight that. So there's different opportunities to manipulate like that. Oh, we are approaching almost out of time there. Okay, we see a good comment here. Let's see if I can take a second to digest this and see if there is a question there. Sharing, more thought on sharing, brand names and logos in some kind of science fair competition. Potentially someone could take legal issue with your results. I guess it's a possibility. Certainly in the realm of published literature, we like to think of scientists being able to act independently, and you get to communicate your results no matter what they say in regards to a manufacturer, but perhaps for science fair that would be a consideration. I guess the thing I would think about when making that decision is, like, does it really matter if you communicate a brand name or not? And if it doesn't, then you can make the choice to leave it out. Excellent point, Karen. Thanks for coming today, Karen. I appreciate you being here.
Cool. Now we've kind of arrived at the finished product for this advanced version of the graph. One thing I was thinking about is how it's kind of nice that you see what happens when you play by the rules, like you follow exactly what the graph wizard suggests, but then it takes like a little bit of an artful approach to get to something that really clearly communicates what the data is saying. And I'm just imagining back to when I was a student and a teacher, how I definitely tended to be more left-brained and like follow the rules and how to get something exactly right. But when it comes to representing data, there's opportunities for some of you more, I know this isn't an accurate term, but the people who are more creative, the right-brained thinkers, who are going to be more maybe willing to experiment with color, with spacing and design, can really help a graphing reach its potential.
Yeah, and I think there's a lot of scope for creativity in science, and that we tend to think of science as very, very right-brained. But I think there's a lot of room for creativity in the design of the experiments, and also, like you said, in the communication of the results. And there is really an art to it, and it can make a big difference in how effective you communicate those results and the way you use those things. Yeah, I see a question from Ginny. Is there a reference for some of these terms so I can help kids with the 95% confidence interval versus the median or the standard deviation? I don't know that we have a reference like in terms of just like a glossary of terms, but I think we could actually very easily put one together in the follow-up materials to this of, hey, what are things you can consider? What are they? What are the definitions of those? And where do they? Where do you control them? We can think about that for this. Yeah, and then Tiffany says you'd be interested in more of these paired examples you could share with students as a bell ringer, or finished early examples, show both graphs, ask which is better and why. Yeah, we'll send these out. And so certainly the 4 examples that we had here today, we could possibly make some more. I mean, we can do this with literally almost any graph that we go through. We can make sort of a basic, and we can make an enhanced version. Yeah. Okay. Well, Blake, any parting comments before we sign off?
No, just really appreciate everybody making time, on a evening in the middle of the week. And again, we'll send out the recording of this webinar as well as a feedback form. We appreciate your thoughts on how we can work on improving these, because these last couple webinars were the result of recommendations we got from attendees.
Yep. And with that, I will say, thanks for coming, and drop us a line if you guys have any questions at all. We'd love to help you out.
Thanks, everybody.